this is part number 2 of the KoiLoader sample. In the previous video we downloaded the sample from Malware Bazaar and had a look at the first stage, and what we're doing with this is looking at the second stage in detail. We're going to then have a quick look at the next stage, and then the next video we'll be looking at stages 3 and 4, I believe. Well, it loads 2 scripts at the same time, and I'll look at those in parallel. So just a brief summary of what we got to last time. If I go back to here, this is the first stage explained. So it is essentially creating this ActiveX object which only runs within IE, it doesn't run within modern browsers, and then using PowerShell to download this, grab content from this PHP page on this domain, and then it's saving it in the temp folder as this.js. And then we looked at some use cases for detection content. So second stage, let's have a look. If we go to, this is basically the URL we saw from the first stage. This is the contents. If we pull this out, just immediately looking at it here, it is pretty difficult to read. So first thing I like to do is just dump it into CyberChef and run this generic code beautify. I'm not sure why there's a thing at the beginning there. I just copied that body tag. This won't run now, it's probably broken. The JavaScript one would be better, but it doesn't seem to work whilst testing it. So if we just use the generic one, it just makes it easier to read. So if we dump that into our second stage.js, we can start to look into what this is. As with most samples, even with the beautify, it is a bit hard to read. So what we'll do is just every new variable declaration we'll put onto a new line. So new variable, new line, new variable, new line. There's one. You can see it's in red as well, so it means it doesn't like it on the same line. Put this. I'm not going to completely tidy it up in this file. What I'll do is I'll show you the before and after, but just to kind of get a general sense of our surroundings. It isn't that obfuscated, which is good for this example, and partly why I picked it, because I want to really get to the point of what it's doing, not kind of deobfuscation for hours. But there's some very basic techniques. So it is essentially taking a string and then splitting it up by declaring parts of that string as different variable names, so like f1, f2, f3, and then it is concatenating them together. So if I put this back together, so I take the value of f1 and I'll replace it there. I just need to quote at the beginning, and that pipe is not used. Then f2, so do the same here. If you're following along, what have I done there? Let's try that again. F2, replace that. It's starting to kind of make a bit more sense in kind of reading it now. And then F3. F3, sorry, here. And then remove all the concatenation. So just for your awareness, in JavaScript style languages, concatenation is done with this plus. So like a string in quotes, and then a plus, and then a variable will basically put the value for that variable in the middle, essentially, when it's ran. So what we've done is just taken f1, f2, f3, and then replaced it on there, so we can delete this as it's not being used anymore. And then we know this first line. So the first line is essentially, it's creating a new ActiveX object, which is similar to the first stage of the sample. And this one is now creating a file system object. So let's have a look at that, what that actually means. And I'll just fast forward to the fully deobfuscated and explained version. So first line is, this code sets up a object or var object is probably called file system object, and this manages files and folders. So what does that mean? If we go to here, sorry for the flashbangs, this is in VBA an object. So I'm not going to explain object-oriented programming, but essentially there's objects, methods, and classes. This is an object, and this has various classes which can essentially do different things. So when it's called via script, you can essentially use this class and the methods within it to run certain actions on an operating system. So for example, copy file, which is one we're using further on, create folder, folder exists. It can do things like check if file exists, delete files, create text files. It can do quite a few things, and it is used in this second stage. So once it's created this file system object, the next thing it does is creates a new variable called ToBeScript shell, and then it does a similar thing where it's creating a ActiveX object called ToBeScript.shell. So this is essentially similar to this, but it's creating like a shell instead of like a file system object. The next line is doing a couple of things. So first of all, it's getting this object here, Win Management Root, Sim v2, and then Win Processor equals CPU08. To put this into plain English, it's essentially getting this object and then checking the CPU value, and then if it is 64-bit, it sets FLDR to sysfile64, and if it is a 32-bit operating system, it sets it to this variable here, FLDR to system32. So essentially, to put it even more simply, it's checking if it is a 32-bit or 64-bit operating system, and then assigning a variable like a string to a variable based on which one it is. We can check this, and the way I did this is essentially just kind of copy this into Google. So if I go back to this page here, and then run this, and then we go to Win32 processor class. Don't need this anymore. If we scroll through to here, there's an example somewhere on this page. So in this example VBS script, how to use this class here to determine a computer architecture, which is pretty much what we're seeing in a script. So all I've done here is just go to like Microsoft Learn, which is a fantastic resource, and then kind of check what we saw in our script against what it is. And essentially it's telling us that it is just checking the computer architecture and then assigning a variable based on which one it is. So that's all well and good. What is it doing next? So now it is essentially building a path to PowerShell, but it doesn't know where this sits on the system. So it could, PowerShell could be sat in, I don't know, maybe if the system root was installed in a D rather than C for some weird example, it would be in C, sysfile64, for example, if it's 64-bit, Windows PowerShell, and then PowerShell.exe. So it's using this variable above here, depending on if it's a 32-bit or 64-bit, in the path, similar using concatenation that we just described. And then it's using the environment variable for system root, which is essentially what is a root of the system. In this case, it's probably likely to be C Windows in most examples. So this would look like C Windows, sysfile64 if it's 64-bit, and then Windows PowerShell. So long story short, creating a path to PowerShell. Next, this is taking this variable, what am I talking about? This is taking this registry key even. It's reading regread via BJG, which is the WShell script. So essentially it is using WShell script dot regread built from here, and then it's reading the value of this registry key, machine grid. Now, if I go to my registry and I go to this path, we can have a look, and it is essentially the value data is this long grid. This is a VM. So it's then taking the character R, prepending the machine grid with R, and then adding another r.js at the end of it. So essentially it's creating something R grid ID and then r.js at the end. The next bit is an if statement. So it's saying if wscript.script name is not the name of the GUID for the machine, and we can see essentially what wscript.script name is. So if I run a script I made earlier, wscript script name, and then you give it the name of the script, it gives you back the name of the script, which in most cases isn't awfully useful, but essentially it's just checking if the name of the script is this yet, and if it isn't, then it's copying copy file. So it's using this copy file which we showed it earlier, and then it's putting using the essentially copy file script name to program data, and then the name of the script is this, which was defined earlier, so the R machine grid r.js. So just to summarize this bit again, because it's a bit chunky, it is, if it isn't the name of the script already, it is copying the script to program data and then using the registry key GUID with R's at the end and beginning .js as the actual name of the script. Okay, next bit. Here it's creating a mutex. So a mutex is used by malware a lot of the time to check if it already exists and then acts depending on if it exists or not. So mtx name is this string of characters, and then it's doing essentially creates a path to this in the temp. So it's basically creating mtx file is this path here to the temp environment variable, so the temp directory plus this name, so temp, so it'd be in temp and then this, and then it's trying to do a try catch statement to say delete it essentially. So it's trying to say file system object, which is defined way up here, delete file this. Obviously if it doesn't exist, it can't delete it. So it basically clears it up if it was already there, so it can run the next bit. And then it's doing a check if it exists. So basically, after it's tried to delete it, check if it exists, and if it does, or if it doesn't, because it's a bang or exclamation mark, it then runs PowerShell command with wscript.shell, which we saw earlier, and then which takes RD, so you can see here RD, and that was the path to PowerShell, and then it sets the PowerShell environment variable paths to the value of the mutex. So essentially it sets this path's env here, env paths to this mtx name, and then after that, so we've just to go back over this bit again, bbj is wscript shell, so it uses it basically creates a shell using ActiveX object to run this command PowerShell, and then sets the path to the mutex name, then invoke expression, which essentially means execute, invoke a web request, which means make a web request to this next part, so this stage 3 essentially. So long story short, it is downloading and executing this PS1 script, and then setting before that it set the environment variable paths to this. Then it's doing this weird bit, which I don't really understand completely, but it's setting the value here, ff, based on if this string here contains this, and it does. So it's basically saying this is true. Don't know why at this stage. We might find out in stage 3 if this is used, this ff. Spoiler alert, probably is. And then finally, it's just doing another invoke expression and then invoke web request to download and execute this. So that's a bit of a mouthful, but hopefully this all made sense. If we want to look at creating some detection content, so examples, probably reading like a script file, reading this path key. So read of this would be a good one. I imagine it's not seen very often by scripts, and it can be definitely tuned down to a point where that would be good. What else is it doing that's really obvious? I mean, any use of ActiveX objects, processing object, so use of this. Probably suspicious. Same with use of this. DvScript.shell. That is also obviously an ActiveX object. Probably creation. Writing to temp directory as well. So write to temp and this will be deletion of temp. So things like that, scripts like deletion, writes to, and then this is probably like use of that. PowerShell use of. Oh yeah. I'd imagine it's not seen a lot. Again, if it is seen, it can hopefully be tuned down to just the things that we want to see. So those are some kind of detection ideas. Again, your mileage may vary with these. They might be completely terrible ideas, but essentially what we want to get kind of build is the idea of reading through a script, picking up the things that you think might not be too common within an environment, then searching for it based on the logs you've got. Again, obviously you can't create detection content if you don't have good logs, but assuming you do, then you could create these detections, test it, see if we see millions of events per day, or if it's in the 10, that's probably not possible, but if it's in the 10s or 20s of legitimate stuff, hopefully you can just tune those out, and then you've got some detection content. And you might even already have detection content that looks at this kind of stuff. Wouldn't be surprised if some of it already exists out there in various tools. I've not been mapping these to kind of MITRE, but you can do. I just didn't want the videos to go on much more than 20 minutes per video. Hopefully this was elusive, and we'll get to stage 3. So basically it'll be this and this in the next video. Thank you very much, and see you next time.